Our infrastructure has been based upon judicious planning by scientists and engineers over the last century or century and a half, not necessarily including the impacts of climate change. So as these storms increase in kind of magnitude and frequency, we find our infrastructure lacking. Our increased population pushing into that wildland-urban interface means that we're encountering hazards more often.
Welcome to the Stantec.io podcast, where we speak to our scientists, designers, engineers, and architects who are combining subject matter expertise with cutting-edge technology to develop digital solutions that can help solve the problems of today and tomorrow. My name is Dave Roberts.
And I'm Mike Arsenault. Today's episode will touch on our changing climate, the increased frequency of severe weather events, and Stantec's digital tools that can help communities and organizations prepare for and mitigate the risks associated with torrential rainfall. This, of course, is a big topic, so we've asked two guests to join us today. Dr. Rick Guthrie is a geohazards expert and the brain behind Stantec's slope manager, and Jeff Albee is our vice president of digital solutions and the champion of flood predictor and flood manager.
Rick is from Calgary, Alberta, and Jeff is from Nashville, Tennessee. Thanks to both of you for being here, and welcome to the podcast. So Rick, let me start with you. Obviously, climate change is impacting the frequency of extreme weather events that we're seeing across the globe. Can you explain the various impacts that these events are triggering within our communities?
Thanks, Dave. Yeah. So there's a couple of things that we should kind of go through. The first one is that climate change, and in particular global warming, has a couple of impacts to communities. So one really varies depending on where you are. So you could have, depending on where you live in the world, you could have a kind of a net increase in precipitation over a year, for example, as part of this temperature increase, but you could also have a net decrease in total precipitation. But the other thing that seems to be true is, for the most part, extreme events are increasing both in frequency and intensity. And so, for example, in the Pacific Northwest, in either the US or Canada, the extreme event, and let's define extreme event as the 99.9th percentile, so 1 in 1,000 event. The extreme precipitation event or storm is increasing in frequency and magnitude, in some cases by a couple 100% more than in the past. And so all of this means that even if your overall total yield of rain over a year is lower, we're getting more of it at one time or in individual storms. Our infrastructure, our planning, the way we built out into that kind of wildland urban interface where we intersect with things like hazards, floods and landslides and wildfires and all of the other things associated with some of these extreme events, our infrastructure has been based upon judicious planning by scientists and engineers over the last century or century and a half, not necessarily including the impacts of climate change. So as these storms increase in kind of magnitude and frequency, we find our infrastructure lacking. Our increased population pushing into that wildland-urban interface means that we're encountering hazards more often and that the hazards are fundamentally worse.
Now, if anyone's consuming news, Jeff, we see stories each and every day of how damaging flooding rainfall can be for communities. And that's obviously a big focus of some of the digital solutions that we've developed at Stantec. So why is heavy rainfall so damaging to communities?
Thanks, Mike. As Dr. Guthrie described, our communities can't keep up with the pace of change in this world today. So, floods obviously are the focus of this conversation. That includes things like fires, ocean, land temperatures, even geopolitics. This planetary change seems to be accelerating, and we're building products, science and engineering products that can keep up with this change. So, one of the impacts of the increased intensity and duration of storms that Dr. Guthrie described are that they're causing increased depth of water, increased velocity of water from things like flash and riverine flooding. And those are causing future threats as well to things like debris flow or landslide, as well as fire. So all these new risks are coming about just from the increased intensity and duration of storms caused by climate change.
So Rick, how are communities currently mitigating the impacts of these extreme events, and how should they adjust going forward with these new challenges?
Yeah, that's a great question. So to some extent, communities simply aren't mitigating the impacts until they've happened. And we're all familiar with, famous storms, coastal examples. New Orleans would be a great coastal example of a community that mitigated after the fact. The Vancouver in the November 2021 flood is another great example of a community that managed that after the fact. Now, it isn't that we don't have infrastructure. We do, but that infrastructure is built on a model of climate that is already expired. And the problem is that we've developed into that infrastructure. So I guess really what we need to do as we go forward is we need to work with tools to update our understanding of what can happen and look for options in based on real data and on quantifiable data that we can in turn use to kind of prioritize where we look first.
Jeff, are there challenges with kind of getting communities and municipalities to buy in? It's almost like you're proving a negative. They don't want to put the resources into that flood risk management because you can't really predict what's going to happen in the future. So they just deal with it, as Rick was mentioning, after the fact. So how do we change their thinking of a little bit of work now, a financial outlay now is going to pay massive dividends when these events occur? And as we've covered, they're occurring with more frequency.
Mike, I'd start answering your question by quoting Buckminster Fuller, big fan of Buckminster Fuller, and he said once, "You can't change the way people think. All you can do is give them a tool, the use of which will change their thinking." And that's what we've tried to do with many of our science and engineering products that we're releasing. So many of our communities are reading in the news and seeing quotes like what NOAA had put out recently, predicting a 101.7 increase in flood frequency and a 44.9% increase in flood severity. Communities are seeing their neighbors become harmed from climate change and increased frequency, duration of storms. These communities are taking notice and realizing that becoming prepared for floods is more critical than ever. So planning for floods are obviously a priority for these communities, but most municipalities are on their back foot. The reason is that traditional modeling, traditional engineering is really costly and it takes years to complete, putting it out of reach for many communities. So when we're offering a compelling product that can deliver outstanding results in a fraction of the time, communities are noticing and taking advantage of or trying to buy these engineering outcomes that we're delivering through the tools like Flood Predictor today.
So can you tell me a little bit more about the technology and the tools that we've used to develop these solutions to address the impact of these extreme weather events?
Yeah, I'm excited about that part. This is what I'm good at, Dave. Simply put, we're building a new wave of digital products that extend science and engineering theory by adding data. The availability of huge amounts of data, along with the computing tools to crunch these numbers, offer a whole new way of understanding our world. We're advancing science, advancing engineering with high fidelity models and their data. We're really at a time where we can do what was really science fiction over a decade ago. And on that point, I want to be clear because I recognize our audience is likely scientists and engineers. I'm not saying theory's dead, and I'm not saying we're not using theory, but it does change when augmented with this wealth of data that flows amongst our employees, some of the smartest people on the planet, that when combined, theory and data, we can deliver better science, better engineering, and better design outcomes for our customers.
Rick, you've devoted your career to studying geohazards, and you're using that subject matter expertise to help inform Slope Manager, basically a landslide early detection system. So how do you meld technology and that expertise to bring a tool like Slope Manager to life?
Yeah, so there's a few things that are really critical here. And Jeff actually hit on one of them right off the top. And that is, science is fundamentally about putting forward an idea, a thesis, a model, right? A thesis is just a mental model of how the world works. And then it sets about trying to disprove that thesis. And so one of the key things is that all models are slaves to data, not the other way around. And so if we start acquiring data that says, hey, the behavior is different than we thought, we need to update our models. And so when Jeff talks about bringing in data from vast and enormous resources in ways that we've never been able to do before, like in all of human history, we have never been in the place that we are now, which is to say, we've always been data poor until only, let's say, the last couple of decades. And then we've had data, but we haven't been able to manage it. We haven't been able to, we've had lots of data coming in, but we haven't been able to process that data. And suddenly we're in this sweet spot where we can both accumulate huge volumes of data and process it, and then start to see how that data affects the models that we thought we had worked out, and retrain those models if necessary to produce a better result. So there are a couple of pieces for something like Slope Manager. One of the things that we're able to do is incorporate huge volumes of real-time data at kind of hyper-local locations. So if you have a watershed that you're paying attention to, or a specific slope, we've got high-resolution, spaceborne, like radar, for example, ground moisture. We have data that is changing in real time, and even forecast slightly ahead of real time at your location. And we apply that to a set of curves that have been kind of existing for the last 40 years, but we're actually going better than that, because those curves are deterministic in terms of their ability to predict landslides. As we are taking all of this data and we're compiling it, and we're finding out that those deterministic curves didn't give us a very good picture of the likelihood that a landslide will occur. And so we're developing probabilistic tools that get put into the engine of something that is kind of watching your slope in real time, like Slope Manager.
Rick, say for an example, I live in a mountain town in the Canadian Rockies. How can Slope Manager help the policymakers in my community protect me from a torrential rain event that could cause a landslide? What mechanisms are in place that my community can protect not just me and my family, but also my property?
Slope Manager by itself is essentially an early warning system. And so without some kind of assessment, it probably isn't going to provide you the value that you're looking for. We've got a few other things. So in this mountain community that you described, one of the things that Stantec developed that we're extremely proud of is debris flow predictor. And that's a landslide runout model. It allows us, historically, we've been pretty good at identifying where landslides could occur. We've been pretty good at identifying the conditions under which they would occur, although we're getting better at that part. But we haven't been very good for long runout landslides, or for debris flows in particular. We haven't been very good at saying how big they're going to be, how bad they're going to be. And debris flow predictor does that. And it's this visually intuitive way of determining where these kind of far off hazards that have a long reach and can actually impact communities will go. So if we've gone through a modeling process that allows us to say, hey, these are the receptors, the elements at risk kind of within your community, and this is the hazard that they are threatened by, we can then turn around and say, oh, now we can let you know what the likelihood is for any particular storm that's coming through by watching it with a monitoring program. And as I mentioned before, there is a difference between a deterministic threshold, which just says, for example, in 100 millimeters of rain in 24 hours, you'll get landslides. Empirically, we know that's generally not true. It could happen, and certainly when we get landslides, it's likely that 100 millimeters or more of rain occurred, but it doesn't automatically mean that just because we had high rainfall, we are ergo going to get landslides. And so what we've done is we've developed, as one of those inputs, this probabilistic curve that says this is the likelihood per unit area, per unit time, or per storm that you're going to get landslides. And what that means is if you, for example, live on a fan and you've got a large area upslope of steep ground, the probability of a landslide occurring for you increases. And so we can start to identify what that looks like. And and that gets plugged into something like Slope Manager, and the community can decide for themselves what thresholds. We can make recommendations, of course, but you can decide for yourself what thresholds are kind of acceptable and when they're not. And Slope Manager in particular gives you about a 40-hour warning for what's kind of coming down the pipe.
That's awesome. So in addition to Slope Manager, I know we've got a number of other tools that we're using as well to deal with extreme weather events. And Jeff, can you talk to us a little bit about Flood Predictor and Flood Manager and perhaps what the difference between these two services are?
Sure, Dave. Yeah, I mean, they really do work hand in glove, and they do feed that saying that Rick just gave about where models are enhanced by data. They have a symbiotic relationship in that way. So Flood Manager is really the product that helps our engineers to automate their models. It's enabling the traditional modeling to just be done more efficiently, more effectively in a batch process sort of way. So we're providing engineers with tools that help them to run their models faster, better, more efficiently. And in the process, we're capturing some metadata from those models. We're learning from those models, and we're capturing the data that we can then use in our prediction models using machine learning. We're now using deep learning to do that flood prediction model. We're taking the learnings and we're training the models on the traditional engineering, using some of that data to project new outcomes in new areas. Even sometimes without any data in the area, we're finding a really high correlation between the traditional engineering we did in one area and how well it does translate to another geographic area, including different countries and different landscape types around the world.
How do we enable clients to get started easily and quickly with our Stantec.io tools?
So Dave, when we launch a product, we think about more than just getting it into the hands of the people who need it. We're focused on making sure the product is doing all the things you want it to do. These are complex science, engineering, design tools. So that means working to understand your business needs and how this product will fit into your existing operations. So when you invest in a product like Manager, like Flood Predictor, like Slope Manager, our professional services team will work with you to implement it and to integrate it into whatever system you're using currently. And then they'll customize it to fit your business models, your goals, and objectives, your timelines even. So these are complex tools, and we have a whole team of people dedicated to understanding the business requirements and to implementing to meet your ultimate goal and objective.
Rick, as data gathering becomes more robust and technology continues to improve, how do you foresee these tools evolving with that data collection and technology in the future?
Yeah, that's a great question. One of the things that Jeff talked about was our Connect.io platform. Stantec's been really great in having the foresight to build a platform that allows us to expand and grow those tools. And so we've got a development team that can make those changes as we're going forward, that helps us scale the tool as required as we get more and more users, but also allows us to have kind of a menu of ongoing updates as we start getting better information. And by the way, we do. Like, one of the things that we're finding on the science and engineering side by using these tools is that it's causing us to ask questions that we weren't able to ask before. So it isn't that the questions weren't there, it's that we didn't even know to ask them because the tools are giving us new insights. And so the new insights are cascading into their own set of new questions, which has us going back to the data and looking for it and making revisions as we go. And so I think it's a long-winded answer, but I think really what we're looking at is a lifetime of tool improvements that are automatically updated and scaled appropriately through the Connect.io platform. And so that's actually one of the things that's, from a scientist perspective, is really exciting, is you're not fixed in a point in time where you can't ever have any improvements, because revisiting that would be just too intense. We're developing these for future upgrades.
So do you have any examples of where our Stantec.io tools have been deployed to address the impact of these extreme weather events and how that's impacting the communities where they've been implemented?
Dave, I do have examples both in the commercial and in the private and public industries. One example is a real estate investment trust firm, big property owner, in North America primarily wanted to use Flood Predictor to demonstrate or to show the potential risk at their properties to see where they may have outages. And they were working to understand the flood risk, the depth, the velocity of water, in order to assign those criteria to an architecture firm and mitigate those threats, those potential damages. So building a bigger wall, building a thicker wall, routing the drainage potentially through a different area. They used Flood Predictor to just see where the highest risk was associated with their property portfolio. And on the public side as well, we're seeing municipal governments understand that storms are increasing, duration and intensity is increasing, and they're using the flash flood component of Flood Predictor to run historic storms, historic weather events through different municipalities to see the impact of those potential historic storms in new geographic areas, understand the risk to their community and their population.
Dave, I can probably add for Slope Manager, we have some pipeline companies that are currently using them to monitor their pipeline right-of-ways. We have a community in the Okanagan who was affected by wildfire, and they had debris flows, and they had both debris flows and the threat of debris flows actually as an outcome of that wildfire. And particularly in the first couple of years, we were using Slope Manager for them to monitor high intensity storms that might cross the paths. One of the challenges that community had is that the publicly available weather monitoring station, so both the stream station and the precipitation stations, were at low elevations and not really far away, but sufficiently far away from the community that it gave very, very different results than what was going on at their local site. And so we were able to watch that and let them know when high intensity events were coming through and just give warning to specific locations as necessary.
Well, that's excellent. Unfortunately, we're out of time today. It's been fantastic talking with you both, and Mike and I have certainly learned a lot more about how Stantec is helping our communities to deal with extreme weather incidents, which unfortunately are becoming more frequent across the globe. But I feel proud of the work that Stantec is doing to help communities to adapt. So thank you once again for being part of the Stantec.io podcast.